Today we're going to take a look at area of a circle. Before we get started with how to calculate the area of a circle, let's take a look back at some things that we already know. First of all, we'll remember that the radius is the measurement from the origin or the middle of the circle to the edge. We can also say that the radius is 1/2 of the diameter. We know that diameter is the distance or the measurement from edge to edge, but we do have to make sure that we pass through the origin or the middle of our circle. We can also say that the diameter is 2 times the radius. We know that circumference is the distance or length around the circle, or we can also think of this as the perimeter of the circle. Now, when we're measuring diameter, circumference, or radius, we're making linear measurements. So we're going to end up with units that are things like centimeters, or meters, or millimeters. When we talk about area, however, what we're talking about is the space inside of a shape, or the space occupied by that shape. And those measurements are always going to be in units squared. So for example, centimeters squared. Now, in order to find the area of a circle, the formula that we're going to use is area equals pi r squared. We're remembering that for pi, we're going to use 3.14, and we're going to take and use some functions and some things that we already know about bed mass to help us use this formula to figure out the area of a circle. In our first example, we're given a circle with a radius of 13.9 centimeters. I'm just going to underline that so we can easily keep track of that. And what we're being asked to find are the diameter, the circumference, and the area. So we actually have to do this in a little bit of a process, and we have to do a couple of different calculations. So on my circle, what I've marked out is the radius, and again, I know that that's going from the origin to any point on the outside, and I know that that is 13.9 centimeters. That's what I'm being told. So the first thing I want to do is figure out the diameter. We'll remember from one of our previous lessons that in order to calculate diameter, I need to take, or to find the diameter, I need 2 times the radius. So I can do some replacing of that variable with the measurement that I have for radius, which is going to be 13.9. And when I multiply 13.9, that's my radius, by 2, I'm going to end up with a diameter of 27.8 centimeters. Now, for circumference, there are 2 different formulas that I can use for circumference, as you'll remember, but because I'm given the radius and I know that that is for sure 100% accurate, I'm going to use the formula that actually has that radius variable in it. So to figure out circumference, I'm going to use the formula 2 pi r. First thing I'm going to do is do some replacing. The 2 stays the same. The pi I can just leave because I know that that's going to be equal to 3.14. And for the r, I'm going to replace that with 13.9. That is my measurement that I have. When I multiply all this together, and because I'm multiplying the 2 times the pi times the 13.9, I can just enter this all into my calculator from left to right. I'm going to end up with a calculation of 87.292 centimeters. But we'll remember that because I'm measuring in centimeters, I want to make sure that I round back to 1 decimal place. So I'm going to say that my circumference is approximately 87.3 centimeters. Lastly, I'm going to determine the area. So for area, I'm going to write down my formula, pi r squared. First thing I'm going to do is replace that r with the numerical amount. So pi, and then in brackets, 13.9 and squared. But this is where I have to stop just briefly and make sure that I follow BEDMAS. You remember with BEDMAS, it tells me to answer anything or solve anything that's inside of a brackets. Well, I don't have anything there except for a single digit, so that's okay. But then I have to work with things that are exponents. So I actually have to complete this part first, 13.9, and square it, and then after the fact, multiply it by 3.14. So I'm going to leave pi exactly as it is. When I punch into my calculator 13.9 squared, or if you don't have a scientific calculator, 13.9 times 13.9, I'm going to end up with 193.21. And after I multiply that by the value of pi, which again we're using 3.14, is going to equal 606.6794 centimeters squared. But again, because I'm dealing in centimeters, I do need to make sure that I round back to 1 decimal place. So my final answer for the area of this particular circle is going to be approximately 606.7 centimeters squared. All right, the next thing we want to do is to take a quick look at how diameter, radius, circumference, and area are actually related to each other. So in a moment, what I'd like you to do is, using the measurement of, for the first set of calculations, radius equals 5 centimeters, you're going to figure out the diameter, the circumference, and the area of a circle that would have a radius of 5. Then I want you to figure out, if that circle had a radius of 10, what would its diameter, circumference, and area be? So that's part 1. But part 2 is to then compare your answers and look for some patterns in how the numbers change. And we want to think about why that possibly is and why that might actually happen. So take a moment and try those on your own. All right, so when we've taken a look for the diameter of a circle with a radius of 5 centimeters, what we've calculated is that that diameter is going to be 10. When we double the radius, what we're going to figure out or calculate is that the diameter is going to be 20. So what we have here is actually something that is doubled. So if I double the radius, I'm going to double the diameter. When I take a look at circumference, what I have is 31.4 for my radius of 5 centimeters and 62.8 for my radius of 10 centimeters. And again, if I think about how those numbers relate to each other, what I've done, or what has happened, is that those have been doubled. Now, when I'm calculating the area for a radius of 5 centimeters, I get an area of 78.5. When I calculate the area for a radius of 10 centimeters, I get 314. And hopefully, with your calculator, you've realized that the relationship between these is actually 4 times greater. And the reason for that is because we've taken something and we've squared it. So because we are no longer working in a linear fashion, right, that is why we are changing the relationship between how those numbers are related. So if I double the radius, I'm going to get twice the diameter. If I double the radius, I'm going to get twice the circumference. But if I double the radius, my area is actually going to increase by a multiple of 4.